Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video we write a Java program to input an integer n and print all the lucky numbers which are less than n. And this question is going to be beneficial for all those students who are going to appear for their ISC Computer Science practical papers, because questions like this and similar to this are often asked in the board exams of ISC Computer Science practicals paper. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers only 1 or 2 are subscribed and a subscription is very important. So please do subscribe to my channel. Alright, so let's begin. So we have to read an integer n, okay, and then we have to print all the lucky numbers which are less than n. For example, n equal to 25, these are the lucky numbers. Now what are lucky numbers? This is the Wikipedia entry for what a lucky number is, okay, and there is a very nice explanation and there is a very nice animation on how to find lucky numbers, okay. So if you want, take a minute and give this a reading, okay. So basically what is happening, in order to find lucky numbers, for example n is 25, lucky numbers less than n, oh, so 25 is not being included, okay. So lucky numbers less than 25 are this. Now how do we calculate it? So we pick out all integers from 1 to 25, less than 25, that is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, okay, 1 to less than 25. You remove all even numbers, okay. So when you remove all even numbers, okay, you remove this 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, okay. So idea of removing all numbers was that you remove every second number. So starting from 1, every second number is going to be 2, 4, 6, 8, 10, 12 and so on, okay. That's why you remove every second number. So after removing every second number, we are left with this. So in this we remove every third number, because this is the next entry in this list which is not removed. So every third number that we are going to remove here will give us 1, 3, okay, and we remove 5 because this is the third entry starting from 1, okay. So we have 7, 9 and we lose 11 because it is another third entry from first, 1 second third, 1 second third, okay. Then again we have 13, 15, we lose 17 because it is another third entry. Then we have 19, 21 and then we lose 23 again because it's the third entry. So every third number in this is removed, okay. What we are left is with this. So the next entry is 7, so we remove every seventh number, okay. So 1, 2, 3, 4, 5, 6, 7, so we remove 19. So when we copy this and remove 19, okay, we are left with this, okay. Then we are left with this and the next entry is 9. So we remove every ninth number, 1, 2, 3, 4, 5, 6, 7. There is no ninth entry in this list less than 25 that we can remove. So this is the final set of numbers which are lucky numbers, 1, 3, 7, 9, 13, 15 and 21, okay. That's how you find lucky numbers, okay. And you can try the same with 1 to 100. You list all numbers from 1 to 100, remove every second number, remove every third number, then you are left with 7. So remove every seventh number, then you are left with ninth, remove every ninth number and you will get this, okay. So first I am going to write the main quickly to read an integer n, okay. Scanner system dot in, okay, scanner dot close, okay, system dot out dot print, enter n, okay. So I say int n is scanner dot next, okay. Then I call the function, okay, find lucky numbers less than n and I pass n, okay. I have to write this function now. So I'll say static void find lucky numbers takes an integer, okay. So find all lucky numbers less than n, okay. So n is not included, okay. You have to find lucky numbers less than n, okay. For example here in 100 less than 100 and for 25 less than 25, okay. So the first thing we do is create an array of size n. So int ARR equal to new int n. Okay. Now set all indices to value I, that is for int I equal to 0, I is less than n, I plus plus, you set the ith location to the value I. Okay. Now location 0 is going to be redundant in this case, because in our case to find lucky numbers we start with 1, we don't start with 0. Okay. And we are taking an array of size n because we have to go from 1 till n minus 1. N is not to be included, that's why we are not taking n plus 1, we are taking n. Okay, and setting all the indices to their corresponding index I value. Okay, so step 1, okay, I remove all the even numbers. Okay, remove all even numbers. Okay, so I start with 0. Okay, go to less than n plus equal to 2, set AR of I to 0. Okay, all right, and I am setting all these values to 0 because I am going to finally print out the values from this ARR array which are not 0. Non-zero values will be the one which are left and which will be the lucky numbers. Okay, now step 2, okay, we do the remaining process. Okay, remove every jth number starting from 3. Okay, starting from 3. Okay, so every second number we removed, then we are left with 3, so we have to remove every third number. So I start my j with 3. Okay, and I go forward as long as j is less than n. Okay, 3, then whatever value remains 7, then whatever value remains 9, till this value is valid within this range. Okay, remove every jth non-zero value in the array. Okay, so that is to remove, for example, when we were here we had to remove 5, which was a non-zero third value, non-zero third value, non-zero third value. Okay, that's what we do here. So I start with m equal to 1, which is my starting index, and I will remove every jth number as long as it is within the valid range. Okay, for example, when we were removing every third number, we started with 5, 11, 17, 23, and then we stop because after 23 we go out of the bounds. So m is the index that we will be setting to 0. Okay, and this has to be within the range. Okay, so I say int count equal to 0. Okay, now this count is going to store how many values that I have skipped. Okay, for every third value I have to skip, every 2 values I have to stop at the third value. Okay, so I say while this m less than n, okay, if I get a non-zero value, AR of m is not equal to 0, I increment the count. Okay, and I stop going forward if my count equal to j. Okay, else I do m plus plus. Okay, so what this loop is doing, basically it is starting with j, which is basically 3 here. So if you take example of 3, you understand it clearly. You start with j equal to 3, which is basically removing every third non-zero value, which is removing 5, 11, 17 and 23. Okay, so my m will be all those indices that I'll have to set to 0. So m will be this 5, 11, 17 and 23. Okay, so that's why m has to be within the range. Now I'm taking this count so that I understand how many values do I need to skip, which is equal to j. So every time I find a non-zero value, I increment the count. The moment I have traversed 3 values, I break, otherwise I keep incrementing the index. Okay, now if count equal to j, okay, so this loop will break either if m crosses n or count equal to j, but I set the mth value to 0 only if I have skipped j number of values. Okay, if m goes out of the bounds, if m goes out of the bounds here, okay, I don't set this ARM to j, I will get an index out of bounds. Okay, I will set ARM to 0 only if I was able to skip j number of values, j number of non-zero values. Okay, all right. Okay, so now this will remove every jth non-zero value in the array, and my first set of values that I need to remove is every third value. So I start with j equal to 3. Okay, now I have to find the next j. Now what do I mean by finding the next j? That we were removing every third value first, and then the next j is going to be 7 because you have to remove every 7th value. Okay, that's why we lose 17 here. Okay, so how do you find that? You set m equal to j plus 1. Okay, So m is again iterating our indices, and it starts with the next index right after j. So starting from this index, wherever I find my next non-zero value, that is my next j value, next value of j. Okay, what I'm trying to say is my j equal to 3. Okay, I start with this index, okay, right after 3, and the moment I find a non-zero value, which is this, okay, I stop. All right, so I say while m is less than n and ARR of m equal to 0. Okay, I keep moving forward. Okay, and I set j equal to m. Okay, and I am able to set j equal to m because each index basically holds its corresponding value, that is ARR I equal to I always, all throughout. Okay, we just are setting values, certain values to 0 because we are eliminating all the numbers which are not lucky numbers. Okay, so after this loop, okay, till j is less than n, when we are here, this loop breaks when j crosses n, and this is where we have all our lucky numbers in this array which are non-zero. Okay, so print non-zero values. Okay, so sys out lucky numbers less than n plus r. Okay, for int I equal to 0, I is less than n, I plus plus. If ARR of I is not to 0, sys out ARR of I plus a space and finally change line. Okay, so let me run this for 25. So 1, 3, 7, 9, 13, 15, 21. Let me run this for 100. 33, 37, 15, 21, 25, 31, 33, 37, 43, 49, 51, 60. Okay, all right. So in this example, we have till say 320, 328. So I'll input 328, 328. So 328, let's compare. Okay, we have 327, 321, 319, 307, 303. All right, so this is correct as well. All right, okay, so I can show you the array. Let me just create a print array method, static void print array. Okay, int arr. Okay, so I take this. Okay, so I say sys out, I want to print it as an array, right? So system.out.println. Okay, and sys out arr. Okay, so okay, let me just take a smaller example of 10. So I'll print array right before, right after I set all values to, all even values to 0. Okay, okay, then I set it after I remove every jth value. Okay, so I'm going to enter 10. One second. So I'm going to enter 10. Okay, so all even values are removed, then every third value is removed. Location 0 is redundant, so let me just take out location 0 and then print again. Okay, so okay, every even value is removed, 2, 4, 6, 8, then every third value is removed, so 5 is removed. Okay, and that's it. 1379. Let me make this for 26, 25. Let's make it. Okay, so we have all even numbers removed. Okay, then every third value is removed, so 5 is removed, 7, 9, 11 is removed, 13, 15, 17 is removed, and 23 is removed. Okay, then let's try it for, let's say, 50. Okay, so all even values are removed. Okay, then every third value is removed, so 23, 27, 29, then 31, 30, 35, 37, 30, and 41, 43, 45, 47. Okay, these are set to 0. Then every seventh value, 1 2 3 4 5 6 7 19 is gone. 1 2 3 4 5 6 7 39 is gone. Okay, then every ninth value 1 2 3 4 5 6 7 8 9 27 is gone. Okay, 1 2 3 4 5 6. Okay, then after 9 13 1 2 3 4 5 6 7 8 9 10 11 12 13. Yes, 45 is gone. Okay, and then it remains the same throughout. All right, so this was the solution to this problem, and I hope this was helpful. So if there is anything that you did not understand in this video, or if there is any doubt, please let me know in the comments. I always try to answer all your doubts in the questions, and I will also add the link of this code in the description of this video. You can check it out. And there are a lot of similar questions that I've already solved on my channel. I will add the links to some of those videos in this description of this video. You can check it out. So please let me know your thoughts on this video, and you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. Thank you.